morning, students. Today we are discussing about NEET mock test 1 conducted by RIITS KOLLAM. As we already know that biology, in the case of NEET examination, biology is the most crucial part because it shows almost 90 questions. From that 90 question, 45 from zoology and 45 from botany part. So today I am discussing about the 45 questions of botany part. And we move on to the first question. The first question is gas vacuoles, single envelope system, cytoskeleton, non-cellulose cell wall, microfilaments, cytoplasmic streaming, lack of any cell organelles. And this is a box column. See the box column, this is a box column. And how many of the above features are associated with prokaryotic cells? And how many of the above features are associated with prokaryotic cell? Okay, so options. Option 1, option 2, 4, option 3, 2, option 4, 3. So here the 4 options are there. See the box column itself, we can identify that gas vacuoles, it is present in, see, in the case of prokaryotes, prokaryotes consist of gas vacuoles. It is meant for buoyancy, floating. We already know that in the case of certain blue-green algae, that is in the case of BGA, gas vacuole is meant for buoyancy. In the box is the first option, that is a gas vacuole is meant for buoyancy in the case of blue-green algae. Clear? Then, so this is present. So gas vacuole is present in the case of prokaryotic cells. Then, second one is a single envelope system. In the box itself, the single envelope system. In the case of single envelope system, we already know that in the case of prokaryotes, membrane-bound cell organelles are absent. We already know that. Membrane-bound cell organelles are absent. That we will study in our lower class itself, because membrane-bound cell organelles are absent in the case of prokaryotes. So all the inclusions present, all the materials present inside a single membrane. See, this is the case of prokaryotes. All the inclusions, that is nucleoid, ribosomes, then rest of the things, all cytoplasmic substances are present inside a single envelope system. So membrane-bound cell organelles are already absent, so there is no double membrane cell organelle, there is no single membrane cell organelle, only non-membrane cell organelle, that is ribosome is there. As you know that ribosome only the cell organelle which shows a non-membranous outline, and here there is no double membranous, there is no single membranous, only non-membranous ribosome is present. So all the substances present inside the jelly-like matrix or cytosol consist of, it is enveloped by a single envelope system. So in that case itself, the second point, single envelope system is also present. So out of this much options, 2 will be there. Then next one, cytoskeleton. Cytoskeleton usually seen in eukaryotic cells. It is usually seen in eukaryotes. Eukaryotes, it is only seen in eukaryotes, and we already know that it is absent in prokaryotes. But in the case of latest research, it is mentioned that some sort of cytoskeletal-like elements are present in prokaryote, but it's not updated in our syllabus. So instead of that, cytoskeletal elements are absent. Generally, it says that cytoskeletal elements are absent in the case of prokaryotes. So our another structure illa, only eukaryotes have cytoskeletal element is there. So further, that's wrong. Then non-cellulose cell wall. In the box itself, the fourth one, non-cellulose cell wall. Okay, that's absolutely right, because in the case of prokaryotes, instead of cellulose cell wall is made up of, purely made up of peptidoglycan. We already know that cell wall is made up of peptidoglycan and there is no cellulose. So peptidoglycan, it is purely composed of sugar and amino acids. Sugar and amino acids. And each peptidoglycan, see, each peptidoglycan consists of sugar and amino acid that is purely composed of NAM and NAG. NAM and NAG. See, I've drawn a picture of prokaryote with prokaryotic cell wall. See, like this. If a prokaryote consists of cell wall, it consists of both NAM, NAG, NAM, NAG, like that. NAM, NAG cell walls. And that both NAM and NAG is composed of sugar and amino acids. And NAM stands for, see, NAM stands for N-acetyl muramic acid. NAM stands for N-acetyl muramic acid, and NAG stands for N-acetyl glucosamine. N-acetyl glucosamine. So, in the case of prokaryotes, it is cell wall is purely composed of, see, cell wall is purely composed of peptidoglycan, or sometimes it is generally called as murin, and it is made up of NAM and NAG composed of sugar and amino acid residues. And here NAM stands for N-acetyl muramic acid and N-acetyl glucosamine. These are the two things present in cell wall of bacteria. And another important question that is already asked in our NEET entrance examination. See, the penicillin, the antibiotic penicillin specifically inhibit which part of the bacteria? In which part of the bacteria? Penicillin inhibit which part of bacteria? That's already it's a previous question. Usually penicillin inhibit cell wall or peptidoglycan of bacteria. Clear? So back to the point. Our option is gas vacuoles, single amino system, and cytoskeleton, non-cellulose cell wall. So non-cellulose cell wall is also right. So three options are there. Then next is the microfilament. Usually microfilament is a cytoskeletal element. I have already mentioned that cytoskeleton is usually absent in the case of prokaryotes, so microfilament is also absent. The next is a cytoplasmic streaming. Cytoplasmic streaming is the movement of protoplasm inside the movement of cytosol or movement of the cell organelles inside the organism. That is not seen in prokaryotes. It is commonly seen in kingdom Protista, Protistan members. It's a common feature in Protistan members. Then, so that is also wrong. So gas vacuole, single ended system, non-cellulose cell wall is also present. And the last one, lack of any cell organelles. Exactly, there is no cell organelles. Membrane bound cell organelles are absent. So our correct option is option 4, 3. So we move on to the second question. Here the second question. Select the correct combination of statements regarding the characteristic features of middle lamellae. Select the correct combination of statements regarding the characteristic features of middle lamellae. Here the first statement. Before we go into the first statement, first of all we want to understand about the middle lamellae. See, this is cell 1 and this is cell 2. In between the cell, there is a structure called it as middle lamellae. It is purely made up of, we already know that it's purely made up of calcium and magnesium pectates. Purely made up of calcium and magnesium pectate. When the fruit become ripened, at the younger stage, this calcium and magnesium pectate act as a cementing agent. But when the fruit become ripens, this middle lamellae, that means it dissolves. This starts dissolving. When the fruit become ripened. So middle lamellae made up of calcium and magnesium pectates. When the fruit becomes ripened, it starts dissolving and the fruit becomes more soft, and it performs maximum respiration rate with the help of ethylene hormone. And also then this is the basic structure of middle lamellae, and middle lamellae, then we move on to the options. It holds the different neighboring cells together. Cell number 1, cell number 2. So our first statement is correct. It holds the different neighboring cells together, or it acts as cementing agent for the adjacent cells. So that's correct. It composed of magnesium pectate. Actual middle lamellae composed of calcium and magnesium pectate. So that is a wrong statement. And third one, it gets dissolved during ripening fruits. Exactly, dissolved during ripening of fruits. So our best choice is option A and C. So option 1 is the correct answer. Clear? Option A and C. So we move to the third question in botany. That is question is that which of the following is associated with detoxification of drugs and muscle contraction by release and uptake of calcium ions? Which of the following is associated with detoxification of drugs and muscle contraction by release and uptake of calcium ions? So here are the options. First one, option number 1, Golgi complex. Option number 2, rough endoplasmic reticulum. Option number 3, smooth endoplasmic reticulum. Option number 4, free ribosomes. So we already know that Golgi. First option, Golgi. Golgi complex act as the major post office of our cell. First function, Golgi is the most important function, major post office of our cell. In our cell itself, Golgi act as the packaging and sorting station itself. That's why it is considered major post office, similar to that of our post office in our area. Because Golgi helps in the packaging system, sorting system, and helps in the transportation system. And Golgi is one of the member in GERL. What are the member in GERL? This is a previous AIMS question. Previous AIMS question. Members of GERL system. The first one is Golgi complex. Okay, GERL system. Now the second function, Golgi helps in all linked glycosylation. Golgi helps in all linked glycosylation. Here the all linked glycosylation means that, see, Golgi, before we go into the all linked glycosylation, so the second function is the all linked glycosylation. As we know that glycosylation is the addition of sugar to the proteins. It's a glycosylation, actually a post-translational modification. Post-translational modification, that is the addition of sugar to the proteins. For it, glycosylation is meant for the post-protein folding process. That's why it is considered as post-translation. It helps in protein folding process, and on that process itself, it moves on the protein trafficking or protein targeting. Okay, so all linked glycosylation. Golgi performs all linked glycosylation. So, dear students, don't forget that in the case of endoplasmic reticulum, it performs N-linked glycosylation. So these are the major difference between Golgi and endoplasmic reticulum. Golgi performs all linked glycosylation. Endoplasmic reticulum performs N-linked glycosylation. Here, endoplasmic reticulum, N-linked means which can add sugar to the protein in its asparagine residue. Asparagine, that is asparagine amino acid, that is asparagine residue. Here students, please understand the difference. See, in the case of Golgi complex, it performs all-linked glycosylation, addition of sugar to the oxygen of serine or threonine. Both are amino acids. Asparagine also amino acid. So this is a fundamental difference between ER and Golgi complex. It's a minor difference, that is Golgi performs N-linked glycosylation, that addition to in its asparagine residue, and asparagine is denoted in its N position, nitro position, and here all-linked means in its oxygen position of serine and threonine. And both these processes act as a kind of post-translational modification, which means that it helps in the protein trafficking processes. So here the N-linked glycosylation and all-linked glycosylation. This is the fundamental difference between Golgi and ER. So here the statement itself, it clearly implies that ER also performs sorting and packaging area. See here, GRL system consists of, see, first one Golgi, second one ER. It's a previous year's question. Then this is a major difference between Golgi and ER. And here the third function of Golgi helps in Golgi helps in cell wall formation. And that's enough for the major functions of Golgi. Then we move to ER. Two kinds of ERs are there. First one, SCR, and second one, RER. Smooth endoplasmic reticulum and rough endoplasmic reticulum. Smooth endoplasmic reticulum and rough endoplasmic reticulum. Here, RER major function is protein synthesis. Because we already know that ribosomes are present over the RIA with the help of two glycoproteins. Ribosomes attached on the rough endoplasmic reticulum with the help of glycoproteins like riboforin 1 and riboforin 2. So riboforin 1 and riboforin 2. This is also a previous entrance question. Clear? Rough endoplasmic consists of ribosome. These ribosomes attach with the help of two glycoproteins called as riboforin 1 and riboforin 2. So, next is smooth endoplasmic reticulum. Smooth endoplasmic reticulum helps in the detoxification of drugs and release and uptake of calcium ions. So, RER, SCR, Golgi, free ribosomes are there. Among the four options, our correct answer is smooth endoplasmic reticulum. And here the one more is there in the case of GR. Let me complete that. See, GR system, Golgi, ER and lysosomes. So don't forget this. GR system composed of Golgi, ER and lysosomes. So students, we move to the fourth question. How many organelles of eukaryotic cells are considered to have an independent existence during early events of evolution? So, this question is purely concerned with the evolution of or the symbiotic theory related to cell organelles. Okay, we already know that in our text itself is clearly mentioned that there is an endosymbiotic theory. Like there are two cell organelles. Which shows its own ribosomes and proteins. So ribosomes and DNA. It shows ribosome. There are two cell organelles which shows its own DNA and ribosomes. As you know that there are two cell organelles which consist of its own DNA and ribosome. So they can simply perform DNA replication and protein synthesis. DNA replication and protein synthesis because of the presence of this DNA and ribosomes. And the two cell organelles include called it as chloroplast and mitochondria. Chloroplast and mitochondria. Clear? And an additional point is both these cell organelles consist of circular DNA, as similar to that of bacteria. And it believes that this both chloroplast and mitochondria derived or originate from prokaryotes. Okay, it believes that. So both these consist of circular DNA. Both chloroplast and mitochondria consist of circular DNA. So its own DNA and ribosomes there, so they can perform. They act as semi-autonomous organelle. So we move to the options. So we already know that there are two cell organelles which has its own DNA and ribosomes. So how many cell organelles are there? Option 2 is the correct answer because only chloroplast and mitochondria is there. So the correct answer is option 2. We move to the next question, that is question number 6. Find out all the proteins that makes eukaryotic flagella. This is a question related to flagella. In the case of prokaryotic flagella, the question is find out all the proteins that make eukaryotic flagella. Okay. In the case of prokaryotic also consists of flagella and eukaryotic also consists of flagella. Here the differences are there. Here In the case of prokaryote, flagella is made up of a protein called flagellin. Flagellin is made up of a protein called flagellin. But in the case of eukaryote, flagellin is made up of a protein called tubulin. Tubulin, that's the first difference. And in the case of prokaryote, flagella is usually proton driven. Flagella is moved with the help of proton and as energy source. Here, eukaryote flagella moves with the help of ATP. It's a fundamental difference. And another difference is in the case of flagella in eukaryotes, it consists of lot of proteins, accessory proteins, like it helps in the movement. Proteins are there. Usually, eukaryote flagella composed of a 9+2 arrangement. And this is composed of 9 peripheral microtubules, 9 pair of peripheral microtubules and 1 central microtubules. We already know that. And here it is considered as this is considered as subfiber B and this is considered subfiber A. This again B and this is A. So linkage is usually AB linker. AB linker. Linkage is usually AB linker. This is structure of flagella in prokaryotes. That is see. So flagella. This is a cross section of flagella, and here this is a linker proteins, and this is a B subfiber, and this is A subfiber, and here this is called it as dynein arms, made up of protein called dynein, helps in the movement, proper movement and alignment. Dynein arms, and there is an outer arm and inner arm is the that you already know that. Then it consists of central 2 microtubule, that is central 2 fiber, that is usually is 9+2 arrangement, and this AB linker is made up of a protein called nexin. So we move to the option. These special kind of proteins are usually absent in prokaryotes. Okay, and we move to the options. In the case of eukaryotic flagella, consists of nexin, tubulin, dyneins. So the correct answer is option 4, that is dynein, tubulin and nexin. So don't forget this, the fundamental difference. This is proton driven and this is ATP driven. It's made of tubulin, it's made up of flagellin. Okay. So we move on to the 7th question, that is the stage during which separation of the paired homologous chromosome begins. The stage during which separation of the paired homologous chromosome begins. Here, paired homologous chromosome bear, that means the separation of paired homologous chromosome begins. That's the question. So we only know that this is a stage where synaptonymal complex dissolution. This is a question from Meiosis, that is synaptonymal complex dissolution begins. That is usually takes place. We already know that synaptonymal complex usually synaptonymal complex dissolution usually begins at diploid synaptonymal complex usually dissolution of synaptonymal complex usually begins at diplotin stage. That we already know that, because in this case also chiasmata or knot formation takes place and terminalization begins. Terminalization not complete, it begins. So it means that after the crossing over, after the packeting crossing over, the chromosome starts separation. That means it's fully formed synaptonymal complex starts dissolution. This is a fully formed synaptonymal complex. Fully formed synaptonymal complex in packeting. After the crossing over, this fully formed synaptonymal complex starts dissolution. Here the distance is there. Starts dissolution. Okay, and this should be takes place in diplotin. So, and also terminalization begins. Here the crossing over takes place in this region, but it starts moving to the terminal region. But this terminalization completes, fully formed terminalization seen in the next stage, that is diakinesis. Clear? So our options are there. So here the options. Option A pachytene, option B diplotin, option C zygotin, and option D diakinesis. So here the answer is diplotin. Clear? And students, one more thing, there are some additional points are there. So don't forget that this also frequently asked in our NEET entrance examination. See, these are additional points. Additional points. In the case of diplotin, desynapsis takes place. Desynapsis means again the dissolution of synaptonymal complex. Formation of synaptonymal complex is called it as synapsis, and the dissolution is called it as desynapsis. Sometimes the word should be like this, desynapsis. So don't forget that. And in the case of certain amphibian oocytes or certain vertebrates, this lasts for month to year. At that stage, at that condition, this diplotin is the longest phase in prophase 1 of meiosis 1. At that case itself, diplotin is the longest, and at this stage is called it as lasts for a month to year, and this stage is called it as dictyotin. Dictyotin stage. Dictyotin stage, or it's also called it as suspend stage. So students, don't forget that desynapsis or synaptonymal complex dissolution starts from diplotin. Clear? And it's also called it as desynapsis. So don't forget that words. And sometimes it lasts for a month to a year. And at that case, it's also called as suspend stage or dictyotin stage. At that case itself, pachytene is a not longer stage, diplotin is a longer stage. Clear? We move to the next question. That's question number 8. Reproduction is synonymous with growth in. Synonymous with growth in. That is exactly similar. Reproduction and some other things. So reproduction, that is reproduction, growth is synonymous in. Which kind of organisms? Option 1, most of the fungi and planaria. As we know, planaria is multicellular, so it is not synonymous with. There is no meaning in between reproduction and growth in the case of planaria. And fungus also. it's also a multicellular organisms and unicellular organisms are there, so it is not possible. Reproduction and growth is synonymous only in the case of unicellular prokaryote and unicellular eukaryotes. Unicellular prokaryote and unicellular eukaryotes. So here the options: option 2, desmids, diatoms, protozoans. That's the best option because all the organisms are unicellular. So that's the correct one. Anyways, we move to the third option. Cyanobacteria, it's a eukaryote. Fungi, no. Multicellular. Meiosis, multicellular. So it's not possible. Then option 4, Meiosis, algae and hydra. Meiosis, it's a kind of higher bryophyte. Then algae, not possible. In the case of hydra, multicellular. So the best one is desmids, diatoms and protozoans. So please understand that in the case of reproduction, only synonymous with the growth, only in the case of unicellular eukaryotes and usually prokaryotes. Clear? And the best one is option 2, desmids, diatoms and protozoans. It's a simple question. So we move to the next question. That is question number 9. 70S ribosomes, chromatophores and circular DNA are found in. We already know that the question number 9 itself is clearly mentioned that 70S ribosome. See, this is the case of prokaryote. It only consists of a circular DNA. As we know, prokaryotes consist of circular DNA, and it consists of non-membranous cell organelle, that is 70S ribosomes, and chromatophores are seen. Chromatophores usually seen in some of the photosynthetic bacteria and BGA. It is similar to that of chloroplast. It's similar to that of chloroplast in eukaryotes because this chromatophores helps in bacterial photosynthesis. So this is a structure of a normal photosynthetic bacteria or blue-green algae. Here it's clearly mentioned that bacteria and bacterial blue-green algae consist of circular DNA, so the only 70S ribosome which is non-membranous, and chromatophores are the similar to that of chloroplast in higher organisms and it also perform photosynthesis. So we move to the options. First one, option A, all eukaryotes. Option B, all prokaryotes. Option C, some prokaryotes. Option D, some eukaryotes and some prokaryotes. Okay, see, there's a little bit confusing options there. Option B, all prokaryotes. I've already mentioned that it is not seen, this chromatophore is not seen in all prokaryotes. It's mainly seen in photosynthetic bacteria and cyanobacteria. Rest of the chemosynthetic, there is no chromatophores in chemosynthetic bacteria and some other bacteria. There's no. So option B is wrong, and the best answer is option C, that is some prokaryotes. We move to the next question, that is question number 10. A bacterial cell divides every 1 minute. So here the question: every 1 minute bacterial cell divides. Every 1 minute bacterial cell divides, that is divides into 2. It takes divides into 2. It takes 15 minutes a cup to be 1/4 full. That is 1/4 of cup. 1/4 of cup is completed within 15 minutes. So it's a simple logic. As you know, 1/4 of the cup, that is 25% of cup, is filled within 15 minutes. We already know that every 1 minute bacteria divides into 2. Clear? So half of the cup is filled within 16 minutes. Clear? And again, full cup is filled in 17 minutes. It's a simple logic. So our question is, a bacterial cell divides every 1 minute. It takes 15 minutes to come to be 1/4 full. Okay, then how much time it will take to fill a cup? So answer is very simple, 70 minutes. Clear? So here the option is D, 70 minutes. Next question, that's question number 11. Endospores formed by certain bacteria are actually the means for. Endospores formed by certain bacteria are actually the means for. So before we go into that options, first of all we want to just understand what do you mean by endospore. This is structure of an endospore. Endospore, and this endospore actually meant for pernation. And it is usually, this endospore is usually seen in species like Clostridium and Bacillus. Clostridium and Bacillus. Actually, this is a kind of special type of spores which is seen in these specific bacteria, that is Clostridium, Bacillus. Two examples, a lot of bacteria are there. This is two examples, and here is meant for pernation, which means that when the conditions become unfavorable, bacteria enters into a pernation stage, that's a suspend stage, that's an inactive stage, but metabolically active, but is inactive. Suspend stage, called it as a pernation. Pernation. When the conditions become favorable, they liberate from endospore and leads to a new organism. Usually, this endospores consist of thick walled structure. Endospore consists of thick walled structure, and usually only one endospore per bacteria. Only one endospore per bacteria. Usually only one endospore per bacteria is usually thick walled, and it helps in the bacteria to overcome the unfavorable situation. Example, Clostridium and Bacillus. So we move to the option. Endospore is meant for option A, reproduction, option B, pernation, option C, bioluminescence, option D, red snow formation. We already know that the right option is option B, that is pernation. I have already mentioned that. And here the option C and D. See students, option C means bioluminescence. Bioluminescence seen in certain members of Ctenophora. They shows also bioluminescence, and certain members of Protista, Goliolax, like that, also shows bioluminescence. And what about red snow formation? That's a crucial point. Red snow formation, option D, red snow formation. See, in the case of red snow formation, sometimes it will be asked in our next examination because it's the wrong one. See, in the case of red snow formation, usually red snow formation is also known as watermelon snow. Snow looks like a watermelon, because when we cut the watermelon, it looks like a beautiful structure similar to that. Snow looks like that watermelon structure. Watermelon snow. It is caused by this watermelon snow or red snow is caused by, it is usually seen in some Arctic regions or Antarctic regions. It is usually seen in, it is usually caused by certain species of Chlamydomonas. Certain species of Chlamydomonas, because this Chlamydomonas consists of a special pigment or special accessory pigment other than chlorophyll, that is called it as astaxanthin. Astaxanthin. Other than chlorophyll, there is a pigment called as astaxanthin, and this astaxanthin helps the Chlamydomonas species to produce a red in appearance, and that is usually looks like a watermelon appearance. That's why it's considered as watermelon snow or a red snow formation. So we move to the question number 12. Difference between red sea and red tide. See the previous question like that, red snow formation, that is caused by Chlamydomonas nivalis, and the next question, difference between red sea, red tide. So three phenomena are there: red snow, red sea, and red tide. See, what is different? Here the question is red sea and red tide. See, it's very simple. Red sea is caused by, red tide is caused by. The very simple concept, red sea is caused by certain members of BGA, blue-green algae or cyanobacteria. Blue-green algae or cyanobacteria. But red tide is caused by certain members of Protista, especially dinoflagellates. So this is a fundamental difference. Red sea is caused by BGA, red tide is caused by Protista. This is a fundamental difference. And here the students don't confuse with red snow. Red snow is caused by another chlorophyll member, that is, I mentioned that red snow is caused by another protista member, chlorophyll member, that is Chlamydomonas nivalis. Chlamydomonas nivalis. So this is the concept of red sea, red tide, and red snow. So our answer is very simple. We move on to the second option, that is associated with cyanobacteria and Protista respectively. Answer is very simple. So don't forget this. I think this one of these phenomena asked in frequent examinations. We move to the question number 13, that is select the incorrectly matched pair. Incorrect. Okay. First one, Mucormucidum. That is coprophilous. That's correct, because we already know that Mucor and Pezaiza both are growing in cow dung. Both are growing in cow dung. Those fungus growing in cow dung is considered as coprophilous fungus. Coprophilous. Then Albugo candida. It's a facultative parasite. Actually, Albugo candida, it's not a facultative parasite, it's a obligate. They show some obligate relationship with the host body, that is usually seen in, it's a kind of obligate parasite. So that's an incorrect option. So we move to the third option, Agaricus bisporus. Agaricus bisporus is a edible basidiocarp. We already know that Agaricus bisporus is usually a mushroom. So it's a kind of edible mushroom. So that's also correct. Option number 4, Puccinia graminis caused by black rust in black rust caused fungus or black rust seen in plants. So that is also correct. So among these 4 options, the wrong one is Albugo candida. That is a obligate parasite. It's not a facultative parasite. So it's a very simple question. And we move to the next question, question number 14. A Doliper septum is a characteristic feature of. So before we go into the options, first of all, we want to understand what is Doliper septum. See, this is a spore of a Basidiomycetes. 2 spores develops leads to a primary mycelium, and when lice come in contact with, this leads to a secondary mycelium. Okay, partitions are there. This is 2 spores of Basidiomycetes. When the spore becomes germinal, leads to formation of primary mycelium, and that primary mycelium combines leads to secondary mycelium, and this secondary mycelium, see, like this. In the case of Basidiomycetes, it's a characteristic feature of Basidiomycetes, that is this is called it as clamp connection. Clamp connection. It's called it, looks like a clamp of our doors. It looks like a clamp of our doors. It's known as clamp connection. This two secondary mycelium combines, leads to formation of a clamp connection, and it is usually looks like a small pore. And what is the importance or relevance behind a dolichopore septum? That is to maintain the nuclear number, to maintain the nuclear number equal, to maintain the nuclear number equal. That's a major function of the formation of dolichopore septum, and it is looks like a clamp connection, clamp like connection. It is only seen in Basidiomycetes. That's why this fungus, this Basidiomycetes group, is considered as a highly advanced fungus. Clear? And so then we move to the options. Dolichopore septum. So what's the function of dolichopore septum? It maintains the nuclear number equally, or even distribution of nuclear number or nucleus, and with the help of a clamp connection. And this is a characteristic feature of Basidiomycetes. It is formed by two primary myceliums combined leads to secondary mycelium. Secondary mycelium leads to further modification. So here are the options: Phycomycetes, Ascomycetes, Basidiomycetes, Zygomycetes. We already know that the best answer is Basidiomycetes. And students, do you have any confusion related to Zygomycetes? Don't forget that Zygomycetes is coming under Phycomycetes. So Phycomycetes broadly divides into two, that is Zygomycetes and Oomycetes. Okay, and the Zygomycetes is also called as conjugation fungi. Classical example: Rhizopus and Mucor. Clear? So we move on to the next question. So students, we move on to the next question, that is question number 50. See students, remind one thing. Next question is also based on biological classification, and this, please students, don't forget that the most important area in botany part is one of the most important part is the biological classification and morphologies, because a lot of questions, lot of examples are there. So usually from biological classification, approximately 5 to 6 questions frequently asked. 5 to 6 questions. So because it consists a lot of examples, especially from kingdom fungi. So be stress on kingdom fungi and protists kingdom. So we move on to the next question, question number 15. Find a set of edible basidiocarps. Edible basidiocarps. Among this, which one is considered as edible basidiocarps? So it's a confusing one. See the first option. Agaricus pleurotus. We already know that agaricus is a mushroom. It's a fully edible part because we consume their that cap-like region, that is basidiocarp, and a stem-like structure. So agaricus is edible. Pleurotus also edible because it's not studied our syllabus, because it's a member of Basidiomycetes. It's fully edible. So it's a correct one. Then we move to the next options because we want to check that. Option B, agaricus and morchella. Agaricus and morchella. In the case of, again, agaricus is the right one, edible basidiocarp. But morchella is also called it as morels. And this morchella, it is also edible. Actually, morchella is also edible, but the thing is that when we take in a raw form, when we take in a raw form, it shows some sort of gastrointestinal problems. When we take raw form, it shows some sort of gastrointestinal problems, that is irritants. It's a kind of irritant. So we never consume morchella or morels in a raw form. It's only consumed by using a semi-boiling. So, and remind one thing, my dear students, this morels or morchella not coming under basidiocarps, it is coming under purely ascocarps, that is Ascomycetes. So that option is, that's why that option is wrong. I'm already mentioned this is a confusing option, because a student which can a clear cut understanding about that examples of all fungal subclassifications. So next, option number 3, Wolveralia and tuber. Wolveralia, actually Wolveralia is a Basidiomycetes and it is fully edible. But tuber is also called it as truffles, morels and truffles, that is studied in our NCERT book itself. But the members are tuber and morchella. So it's again Ascomycetes members. Ascomycetes members. Clear? It's also edible, but it's not belongs to Basidio, it belongs to Asco. So that's why that is wrong. One is Basidio and the one is, that is Wolveralia is Basidio and tuber is Asco. And the next one, Amanita and morchella. Again, Amanita, we already know that Amanita. Again, Amanita is a Basidiomycetes, but remind one thing, it's already Basidiomycetes, but it is poisonous. Poisonous mushroom. It's a kind of poisonous mushroom because this produces a substance called it as alpha amanitin. Alpha amanitin. And this alpha amanitin specifically inhibit RNA polymerase 2. Don't forget this. Alpha amanitin, a mushroom poison called it as alpha amanitin specifically inhibit RNA polymerase 2. Clear? And this RNA polymerase 2 become inactivate. So they can't perform properly. There's no synthesis of mRNAs or something. So it's a mushroom poison. Then again, next one is again morchella. I already mentioned that it's also called as morels. So among these 4 options, the best and most appropriate and correct answer is option 1. So students, please remind just mark my word. Please mark my word. In the case of kingdom fungi, species, different types of examples are there. It's highly important. Okay, students, we move to the question number 16. Oxygen is not produced during photosynthesis. We already know that. As we already know that the options is like this: green sulfur bacteria, nostoc, cara, cycas. Here, cycas, cara, nostoc, they are usually, basically, they are water. They use water as their proton source. If an organism used water as their proton source, they will definitely evolve or liberate oxygen. That is nascent oxygen. Definitely what? Oxygen, nascent oxygen, newly formed oxygen. That's why I am mentioned like this. Nascent oxygen. Definitely evolve oxygen. And my dear students, please listen. In the case of green sulfur bacteria, they never use water as their proton driving force. So here, instead of water, they use H2S. So evolving product is usually sulfur. That's why the wrong option, that is, the correct option is green sulfur bacteria. Rest of the options are water as the proton source. Okay, we move on to the next question. Next question. Select the wrong statement. Again, this is a kind of question. Wrong statement. Cell wall is present in members of fungi and plantae. We already know that. That's a correct answer, because cell wall is present in fungus and plantae. We already know that. Fungi consist of, listen students, fungi consist of a cell wall material called it as chitin. But some members of fungi, their cell wall is usually made up of cellulose. That's the thing. And the member is called it as Meiosis. Meiosis belongs to Phycomycetes. So students, don't forget this. Just focus this. And never forget this. Because already cell wall, we already know that this fungus cell is made up of chitin. Okay, nag. But some fungus, they show cellulose as their cell wall material. That is in the case of Meiosis, that belongs to Phycomycetes. And in the case of plantae, we already know the cellulose, hemicellulose, that we already know that. So that's the correct one. Then mushrooms belongs to Basidiomycetes. In our previous questions, it's clearly mentioned that usually mushrooms belongs to Basidiomycetes. Next question, mitochondria, that's also correct. Mitochondria, the powerhouse of cell in all kingdoms. So, all kingdoms include, you already know that, all kingdoms include kingdom, Archaea kingdom, Monera kingdom, Protista kingdom, Fungi kingdom, Animalia, and also in the kingdom Plantae. So here 6 kingdom classifications are there. This is not by Robert H. Whittaker classification. This is by a great eminent personality called it as Carl Woese. Perform the 6 kingdom classification for the 3 domain system. Okay, he separated the Archaea from Monera because of presence of some branched lipids as their cell membrane system. So Archaea, Monera, Protista, Fungi, Plantae, and Melia. Okay, we already know that mitochondria is present in, mitochondria present in Protista, Fungi, Plantae, and Melia. It is not seen in Archaeas and Moneras. But this is in latest classification, it is separately out. And according to R.H. Whittaker classification, Monerans include kingdom Monera. That means kingdom Monera include Archaea and Eubacteria. So, my dear students, don't forget this. This is a Carl Woese kingdom classification, and according to R.H. Whittaker, according to our NCERT, kingdom Monera, there is no mitochondria, only seen in Protista, Fungi, Plantae, and Melia. So, actually, I mentioned this Archaea and Monera. I mentioned that. Suppose a question is like this, according to Carl Woese or something. So, don't forget that 2 kingdoms are exceptions. So, next one. So, that's also correct. Next one. Pseudopodia are locomotory organs and feeding structures in sporozoans. Actually, sporozoans include plasmodium. And this plasmodium, they don't have any locomotory organ. They only have some non-locomotor agents because they use vectors as for the transmission. So the most deadly dangerous animal protist because it causes a lot of diseases like malaria, elephantiasis, like that. So that option is wrong. Pseudopodia actually belongs to sarcodines. Sarcodines, that is in the case of amoeba. So option 4 is the wrong option. Pseudopodia locomotor and feeding structures seen in not in sporozoan, it is seen in sarcodines or amoeba.